I think I am doing it, but I'm not sure why I can't just put this one only. That's not that camera. Is that camera or is it this one here? This camera is. It's not that. Exactly. So how do I switch it? If you want, you can change it, man.
The camera option is I'm not sure. Oh, okay. Yeah, it might be on there very well. I'm not sure. No. Security participants. Stop video. Video settings.
What time is it? We don't know what pizza is.
Is it possible that you can click on the drop down? If there was this drop down.
Oh yeah, only one camera option is being allowed for some reason. The FaceTime HD camera, this one here, which is okay.
Hang on, I think pizza is funny. Why don't you talk to Vardaan and say, how are you?
Oh,
See
yeah,
if we can.
the better.
Sounds good.
Hello? Yes.
Awesome. Okay. So for some reason, only one camera option.
Connected from the chair, but I don't know.
Yeah, but there's no.
There is like one window.
Well, we don't have an HDMI cable to connect. We only have the one that's given to us. It's already connected to the wall.
How do you know?
That is a great question. How we get the camera up here on is also a good question. Let's see. I'm not pressing that button.
Yeah, because I see like a microphone button next to the power button.
Yeah, I'm not pressing it.
Yeah.
Let's see.
What is that the budget I can?
Mhm.
Desktop.
All right. Either way, this camera will be just fine if we can't use this one, but I don't know why we wouldn't be able to use this one.
Yeah, I think we need to check this out the other day.
Mm-hmm. Yeah, well,
The
because
camera.
it's connected to the HDMI, I would expect that we would have another camera option, a second camera option, other than just the FaceTime HD camera that's on here, to go up here directly. And there's no way to turn the camera on without like restarting the whole
Exactly.
thing. So I believe we're good with this one, which is fine with what we have. Maybe. I don't know. He's busy, not able to be here for a reason. So I'm afraid that if I did that, I'd be interrupting him. But yeah, you'd think the option would be there, and it is not. But again, this camera is okay. But what I don't understand is why this is not showing it anymore.
And there's no one here as well. Yeah, like what somebody who has been here alone just has that.
Mhm.
But
Yeah,
no
I
one's
mean,
there.
mhm.
Their doors are locked.
Yeah. Oh, what a shame. Okay. So this was displaying the screen. It wasn't that. And
How do you like set up like the laptop to the screen? That's how we so
it's automatic. It's supposed to just plug in and it will be there. Yeah, that's how it worked previously, at least, thankfully.
hopefully it should work.
Yeah. Display will not be used. Yeah, it took a moment, but it did it eventually.
I'm just thinking if I can contact somebody. Should I contact Josh?
Wirelessly, this thing. Yeah, it's just a pure wirelessly. I think it's supposed to set up. We should do that. It should just be doing it automatically right here and now.
I'll just call Josh. I'll see if he picks up or not.
Okay, sounds good.
Most likely he'll not, but
All right, sounds good. Okay. I'm very sorry for the difficulty we're having technically here. For some reason, the HDMI cable port is not allowing us to display. It was displaying video for a moment, but it's not allowing us to display the camera. So we'll see what we can do and get it figured out.
Okay, yeah, cool, no worries.
Oh, 1 second. Let me turn the audio up on this laptop so I can hear you. I'm not used to Macs. Yeah, it's maxed out. Okay, odd.
Yep, can you hear me now?
take a phone call?
I don't know. He didn't respond to me. He didn't respond to me on Discord, so I'm not sure. Yes. So it was displaying on the screen. I didn't touch him or anything, and then all of a sudden it's not. I talked to him and let him know, but I can't hear him because there's no audio to the actual phone now because it should be connected to the speakers, but there's no way to.
So what are we doing now?
Yes, I told him and I let him know what was going on, the problem, but it should be displaying audio through here. We are not muted or deafened or anything of the sort. It's picking up our audio, thankfully, but there is no option to
Then take
Other
those
methods.
out.
mix your mind.
Yeah.
This is when you work with other people. So go into
Good, there we go, perfect. What is it on?
It's okay, well, we need to see if we can hear anything. Can we hear?
And then he's.
I was not able to hear, even with the internet.
Do you remember how when I connected from over there, it became?
Yeah, because it was new.
So let's see. Are we now able to hear you or not?
Yeah, I can hear you. I'm
Oh.
audible to you.
Beautiful. So how about this? Would you be able to share the screen and put a slide on and then get started?
Sure. Yep.
Yep, we should be just,
Very good. And we can just get started.
okay, so that was off of that, and now we. Wonderful.
Thanks for that.
Yeah, we couldn't get the camera connected for some reason. The only option for
That's all
camera
right.
is
As
this
long
one,
as we
but
have the presentation and we
Yeah.
record.
we're able to see everybody, so it's just fun.
Yeah, if you want pizza, you can have pizza.
Sounds good.
And then we
All
can
right.
get
I'll
started.
get this out front and center so everybody can have a better view of it. Thankfully, so,
Ah, that looks good.
yes. Awesome.
So I'll take this elsewhere, and I could in principle. Go.
No, that's not it. Well, you're the primary host, so I think you're gonna be there, but it's called. So should stay around here.
Which is, okay, so.
Yes. Right. After that, I believe we could just go.
So are we ready to get started?
I believe we're ready to get started.
Are we ready to get started? So the setup is a little bit different. I'm not sure how loud you can hear me. Let me just quickly ask MWIDENE. I forgot the first name. What's the first name? Could you say something so we can hear you?
Hi, it's Michaela.
Very good, very good. And
Can you hear me?
Yeah, we can hear you. Can you hear
Cool.
me?
Yes, all good.
Okay, so now today, because we are recording, so today we have another presentation about Womanium, and it's going to be Vardaan Sahgal. We have the slide on the screen, and I think we should get started. So we're going to let the speaker proceed with the presentation, and then maybe at the end we're going to ask questions. Is that okay, Vardaan?
Yep.
Very
Sounds
good.
good.
Let's get started.
Okay, yeah, wonderful. Great seeing you all. I am assuming it must be like evening, so a time for dinner, I guess. But yeah, thanks for being here so late, and thanks for joining in. Thank you for inviting me too. Before I start my presentation, just a quick note. This would be a non-technical kind of presentation, so I'm not going to talk about the technical integrities of the work we are doing. Rather, I would make case of the different kind of opportunities we will be opening up, and the different kind of career paths you might choose after your graduation or after you complete your undergrad degrees in the quantum field. I will also talk a little bit about the different projects we are currently running under the Quantum Solutions Launchpad program under the larger Womanium umbrella. So after my short talk, I would rather encourage a more lively discussion with the audience if that's something you're open to. So any kind of questions on the different kind of programs, how you can apply for them, or what is the next steps over here, I'm happy to discuss them right now. And although I do come from a technical background, so if there are any questions within my capacity to answer, I'll be more than happy to answer them along the way. So before I jump into the presentation, a little bit about me. My name is Vardaan, and I come from a physics background. I did my research in atomic and nuclear physics, later in nanomaterials, and finally in quantum computing. In the quantum domain, my core research expertise lies in quantum algorithms and specifically on how to optimize them for the current NISQ platforms and the noisy hardwares available. So you might have heard about Shore's algorithm or some other QAOA or QB formulations. It's very easy to find the demos online and run them on the different cloud services available today. But the problem is when we have these algorithms scaling up to larger problems, larger use cases, the noise isn't our best friend over there. So we need to optimize and fine-tune these algorithms to a much further extent, and that is where I usually come in. So at Womanium Quantum, I head the quantum software and solutions team, wherein we partner with different industries, we partner with different universities, and we prepare students for the future in the quantum domain, but also in the same time develop proprietary quantum software and solutions for different organizations and different partners. So at Womanium, our major goal is to create the best scientific programs out there. We are not a quantum, or maybe I should say, we are not an only quantum company out there. We are a nonprofit organization based out of Washington, D.C. And we have a aim, or we have a goal of creating the most advanced STEM programs. We have been around for the past 8 years or so, and we have been touching different technical backgrounds, started with AI, ML, astrophysics, neurobiology, and many other fascinating topics. Quantum is a more recent one, and also when I joined the organization. So with this quantum thing, the main question was that with this emerging technology, the research areas are very niche, the industry hasn't developed enough, and at the same time, even the university curriculums are not up to the par of what the industry requires. So that is where we stepped in collaboration with a lot of amazing partners and helped fill in this gap between the academia and the industry. And how did we do it? We just asked the best people out there. So we approached some of the most amazing people out there in the technical domains of quantum computing, quantum sensing, quantum meteorology, materials, and much more, and asked them what kind of curriculum would be the most ideal out there. Like, what are the different gaps in the current education which we can fill in and we can help you along? We don't want to reinvent the wheel. We just want to fill in the different gaps which are already there. So we brought all the different people from different domains together and created this cohort. We had more than 70 amazing speakers coming in and helping us guide our courses along the way, which resulted in us creating the most comprehensive quantum training program out there. Last week, I believe you heard one of my colleagues talk about this program in more detail. So Dr. Marlowe heads this entire program. We have been teaching more than 3,000. Currently, the figure is about 4,500 quantum scholars globally, touching about 88 to 100 countries. We not only talk about quantum computing in these programs, we also touch upon the less hyped about fields like quantum sensing or quantum materials and those kind of stuff, and deliver theoretical lectures, but also try to give you a more practical experience by providing virtual lab tours and giving you a step into how the actual quantum computers work. So we do a lot of this stuff, and everything is online. So we make it 100% virtual, 100% free for students by providing them with scholarships and support to pursue this kind of material so that they are well equipped for the technologies that lie in the future. And everything while maintaining a good diversity in a program. So this ties back to our initial goal at Womanium, that was to create more and better opportunities for women in STEM. And that is why we have continuously maintained more than 40% female participation in all of our programs. And we continue to encourage and motivate more women to join our cause. With this program, we taught the students, right? This was the first step in our entire quantum initiative. But the next step was to get these students hired, right? Once we train them, they need to get absorbed right into the industry. So that is where we host a lot of companies coming into our program and directly hiring from our cohort. So you don't need a degree per se to get hired in the quantum domain, just because the skills are very specific, and even the HRs and the different companies are shifting to a non-traditional route. So they are not exactly asking for PhDs today, rather they are just asking for people who can get the job done. So we have more than 40 firms directly hiring from our cohort. And when I say hiring, they are picking up undergrads, graduates, PhDs, postdocs, even certain industry professionals who are looking to switch domains. And we have had a pretty good response rate from both the sides. Even the participants who are getting hired are having a tremendous time working at some of our partnering industries. And on the other hand, our industry are really, really happy by partnering with us and getting the best talent out of here. So this is kind of an opportunity or a gateway to move into the industry directly if you do not want to go the traditional route of doing multiple PhDs or postdocs and then joining the industry. But during the career fair, we realized that not everyone is kind of made to do jobs. Some of them are really, really enthusiastic about creating their own solutions, working independently. And that is why we hosted something called as the entrepreneurship panel and started encouraging and motivating students with their own ideas to just go wild with them, right? So we brought a lot of VCs and early stage incubation support staff from all around the world to help these students and try and incubate their ideas. We are very proud of the 3 startups coming out of our programs. These are currently in formation. And this is something which really, really motivates us to continue doing the good work moving forward, right? Because as I mentioned, if you are doing good at a job, you might be very well suited to join the industry, but some of the students had different ideas. They just wanted to do something independently. They just wanted to make something of their own. And this was the right career path for them, just getting their own firm started. So we had a pretty good success rate in this kind of cohort. But even after getting a lot of people hired, even after getting a lot of people to join their own startups and build their own startups, we realized that some of the students are midway into their education, right? They are not exactly graduated. They are currently in their first, second years, still doing coursework, and they're unsure whether to pursue higher education or to shift directly to the industry. And this is where we took a step back and started talking to all of our partners to create something called as the Quantum Solutions Launchpad. This is kind of a program that sits very comfortably between the academia and the industry. And the way this program is structured is we ask all of our partners, what are the current problems you have, right? So we don't try and produce a dummy problem for you to solve. We just ask all of our partners, yeah, like you are a quantum company, you are working on 100 different problems. What's the most pressing one? Or let's say if you want to get a problem solved tomorrow, what will be the most urgent problem you would like to get solved, right? And when we have those problems in hand, when we have the right questions we need to answer, we just pose the same questions to our students, to our cohort of participants. And yeah, with our success rate, many of the participants are able to solve these questions, answer these questions with the right mentorship and the guidance. And this, in a nutshell, is what Quantum Solutions Launchpad is. We talk with the partners and ask them the right questions. We give these questions to our students, to our participants. We mentor them. We have a different kind of criteria to help them grow along the way. And eventually, when the problems are solved, we just hand them back to the industry. So this is what a program I'm currently heading right now. And this program is run throughout the year on a rolling basis. And you can apply and work on some of the most amazing, with some of the most amazing researchers out there on some of the most pressing real world problems that the industry and national labs are facing through this particular program. A stepwise introduction to the program is we want to create a skilled workforce. That basically means if you are a PhD or a postdoc, you have a pretty good sense of what research looks like in the quantum domain. But what are the different, a different kind of problems that the industry is facing, or what are the different approaches that the industry is taking? That kind of introduction is still missing in your academic career. So this is where we come in. And we don't exactly want you to work full-time. If that's the option, you are more than welcome to join us, but we are also open to students working part-time or come in as fellowships or internships, whatever is the best suitable way out, and give you a taste of what it is like to work in the industry. We work with some of the best researchers out there, both in a mentorship format as well as weekly check-ins, milestone-based evaluation, everything to support your growth along the way. We partner with, as I told in the last slide, we partner with almost 40 plus quantum players. So everyone you might have heard about, right from the giants like IBM or Google to upcoming quantum players like QEra, Xanadu, IQM, IonQ, literally anyone and everyone out there. We partner with them to make your journey as flexible, comfortable as possible, and more so agnostic about the problem. So we don't want to have a more preferred approach that, yeah, use Qiskit and specifically use IBM servers to run your problems. If that's what you want to do, go ahead and feel free to do it. But if you want to try something different, maybe use Penylane from Xanadu, or maybe use neutral atom hardware devices at the back end. It's completely up to you. So we try to provide that flexibility on both our industry partners and as well as to the students, so they can really, really test what they are most comfortable with and grow along the way. So I will like to take a minute over here to describe some of the amazing problems our student cohorts have solved in the past few QSL programs. So these are some of the problems that are now in the public domain. I can talk a little bit more about them, but still not the exact technical details. Some of them have been created as short webinars too. So you can go through our YouTube channel and learn more about them in detail. For example, one of the problems you're working on is about miniaturizing quantum sensing devices and using quantum computing for simulating nuclear engineering, particularly how to simulate Poisson's equations for CFD simulations with the naval nuclear laboratory. And this is some of the most cutting edge technology and cutting edge research work which we have been doing with NNL. So our students have been in close collaboration with their research teams and have been working for the past 8 months, I think now, but the research is still going on and soon it should be published. In fact, for some of the upcoming symposiums, I think at PQI and a few others, the teams will be presenting their posters and the preliminary results of their research. Another fascinating project we did was with NASA back a few years, where our team went in person at the NASA Goddard Space Flight Center and tested their sensors and their communication devices on the James Webb Telescope itself. So our team from Womanium was the only team selected to work hands-on on this particular James Webb Telescope, and we are very proud of the achievements they made. Another part about was quantum sensing devices for carbon capture, utilization, and storage, which is a huge and a pressing problem today. We all need to go green, and one of the key area of focus is to reduce the carbon content. So that usually requires how to capture the current carbon in the atmosphere in our daily lives. And once we capture that carbon, either we need to utilize it instantly or we need to store it for future use. So we are working very closely with the government organizations to make that possible. Quantum computing is making a spread over here on how to come up with new and better, more efficient materials for storage and utilization. But one of the real world applications which we are seeing today is for quantum sensing. That is using quantum sensors for testing what are the different geological sites where we can actually store the carbon deep down under the Earth's surface. Coming back to something you might be a bit more aware of, a quantum company named Xanadu based out of Canada. So this is a company which builds photonic quantum computers, and we worked with them on something called as chemistry simulation. So this is where you have variation quantum algorithms on trying to model how the chemistry works for different atoms and different molecules. But the thing is that even though we have the algorithms in place today, they are just too costly. They are just too costly to run efficiently, and that is why we do not get near a quantum advantage. So our team worked very closely with the researchers at Xanadu and came up with a routine which helped reduce the computational cost up to 90%, which was a huge, huge achievement. And with this, it was kind of a step further in getting to the quantum day, the Q day as we call it, where an advantage will be there. So all this is being done with the industries, like I mentioned. So these are not independent teams. We are working with the industry, and this is the kind of collaboration we want to provide students moving forward. Just another use case coming a little bit on a different track, not quantum computing or sensing, but quantum communication. So we are working with a space startup which is eyeing quantum communication protocols between satellites. Again, a very a futuristic approach and really amazing approach over here is that they want to build quantum secure networks between satellites and Earth stations, which is a huge task in itself. So we are involved with this space startup right from the very first step on their quantum secured communication. We are helping them design photonic chips for QKD and QKD-based protocols. The next step would ideally be putting these photonic chips onto CubeSats and launching them into the space for POCs and first principle authentications. And eventually, if all goes well, we'll be able to launch quantum secure networks between satellites. That's kind of the end goal over here. So all these amazing work are going on. Another success story I would like to briefly mention was with a huge firm based out of Europe. And with them, they basically hold and manage different warehouses. So this is something, again, you can relate from your real life. You all must be ordering stuff from Amazon or some other delivery people, right? You book something on the net, and within the next 2 hours, you have a delivery waiting at your doorstep. To make that happen, all the warehouses today, at least in the States, have been automated, which basically means that there are no more people running around these humongous warehouses searching for the right product which you have ordered. Instead, there are robots which do the task for you. But the thing is that once we shift from manual labor to automated processes, the things become a bit more complex on the technical end. We cannot have 1 million robots doing the task of 1 million humans. That is just purely nonsense. If we are moving to automation, we should reduce the workload. So if we are reducing the number of robots required, we need to come up with better optimization routines, which will use lesser robots to do the same task in a lesser amount of time. And to improve these logistics and optimization routines, we had a quantum computing algorithm developed in-house right from the very scratch, using D-Waves, QAOA, and QUBO formulations to do that. And our team achieved over 66% acceleration in the entire operations. And this is like a huge, huge benefit to our industry partner who, it's like if you're running a multi-billion-dollar operation, even a 1% advantage could mean millions in profit, right? And now imagine a 66% acceleration would create kind of a lottery on the very first day. So right now, the task at hand is to try and bring this quantum computing advantage, which we have achieved, into the actual day-to-day working of the warehouse. That is where the team is currently involved in. But the progress is looking very promising. And everything, just to conclude, that this particular QSL program is kind of a right fit between academia and industry. It gives you a chance of tasting what it is to work on real world problems, not just research problems in the quantum space, and also give you different opportunities to work with some of the best minds out there in the industry. And so that is the QSL, or the Quantum Solutions Launchpad, which we have. As I mentioned, this would be a short presentation, so I would like to wrap up over here. If you want, you can take a screenshot or just take a click of this particular slide. I'm always happy to answer any queries or follow up with me over mail. You can also reach out to me over LinkedIn. And if you do have any questions, happy to answer.
Okay, I think we're gonna have yes.
And just kind of like a bonus thing. As I mentioned, this Quantum Solutions Launchpad program runs throughout the year on a rolling basis. So this is kind of the link to apply for it. So regardless of what stage you are in your undergrad or graduate degrees, your application is always welcome. You can, again, take a screenshot or go to this particular link after after this particular lecture. And we'll be happy to receive and review your applications. Thank you.
You are very, thank you so much for giving us a talk. Now, they're taking pictures here, but we are recording, so they can look at the recording later and then stop it and write down the URL. I wonder how loud you can hear me right now. Too loud or just right? Or
no, it's just right.
Because if they come here to ask questions, I need them to know exactly how close they need to be to the microphone and which microphone is going to pick up the question. I'd like to start the questions by asking several things. And then as we progress, maybe they'll have questions and I'll have more questions. So the questions are going to be in stages. Womanium, is, I mean, advertised as being STEM plus entrepreneurship for women. But the focus that we have explored with you and Marlu is basically quantum. Now, how long did Womanium exist before this focus to quantum, or did it just get started with you guys and mainly it's about quantum?
No, yeah. So Womanium is a pretty I would say it's been around for the last 8 or 9 years or so. I'm not sure if the exact starting date, but it was long before I joined, or for that matter, my colleague Dr. Marlo joined, and we both came in only for the quantum vertical. So Womanium is a larger organization of STEM plus entrepreneurship plus more women in STEM. And when I say STEM, it's engineering, it's medicine, it's scientific, technology, the entire portfolio, right? So Womanium has been working on some pretty advanced programs like neurobiology or astrophysics or machine learning and AI for now. It was only in 2021 when Dr. Marlowe started the entire quantum training program, and a year later I came in and I started the quantum solutions thing. So yeah, we both are pretty recent to it, but and the entire quantum thing is the new, I would say, the more recent vertical at Womanium, but the organization itself has been working on different tracks.
I see, that's very good, which means that since we have not heard about Womanium before the quantum aspect, because first time I heard about this was from Marlu, January 2023. This was a workshop on quantum education organized by Jim Freerichs in Arlington. And that was, as I said, maybe 14 months ago. And I had not heard about Womanium, but this is important for us because there could be classically trained people who would like to participate in STEM and entrepreneurship, not necessarily at quantum, although the quantum is being available, that's very important. So my next question is this. We know of some of these companies, for example, Xanadu is really close to us. I mean, 9 hours by driving to Toronto, but here's one quick question that we have that may be difficult to answer at the moment. We are a computer science department, and the thing that we are interested in is quantum computing. So in general, we can discuss quantum computing without necessarily discussing quantum physics on account that there is already a model. You don't need to know what the Schrödinger equation is about. You don't need to solve it. You don't need to worry about applying quantum physics to real life situations. If you just want to learn quantum computing, you are basically functioning in an already existing model. But now, if you don't want to build quantum computers, you just learn that aspect. But since quantum computers are going to be built by, I guess, computer scientists, which currently are not building those quantum computers, how likely do you think it is that in 5 years we could set up a quantum computing hardware lab in the computer science department? Will it be too expensive? Too expensive for us? Impossible for undergraduate computer science, not physics? What do you think? Is it possible? Can we work with a company to sort of build, maybe not a quantum computer, just quantum gates in some modality, photonics or I guess trapped ions? You think that's a possibility?
Right. Yeah, that's a very interesting question. Thank you, Adrian, for asking this question, because this highlights a dilemma which we are currently in, especially in the quantum technology. And I come across different viewpoints regarding this. My favorite is, and I would, just take an example to pitch it out here. You all use internet, right? Everyone uses different service providers using internet on their mobiles, on their laptops, on different fields. But internet was long back ARPANET, which was a security protocol developed at DARPA. Right. So at that stage, if someone would have asked that, can common users use internet without knowing its intricacies, the answer would have been straight no. The only people who were allowed to use this were defense personnel or the researchers who were actually knowing how to get that working. But today, everyone is using it without even knowing how the internet works. And I'm pretty sure that even being computer science department, if I can just pinpoint 1 or 2 students out there in the audience, I don't think they would be in a good position to explain how the internet actually works, or for that matter, how your smartphone actually works. right? This kind of a stage for quantum computing is still a bit far away. We are very, very early. And although, yeah, computer scientists can start programming without knowing quantum physics, that's absolutely true. And the same goes for quantum people too. Physicists can start building quantum hardwares without actually learning about the computer science, the programming languages. But because we are so early, it is ideal to have at least a little bit knowledge of the other fields, because that would help you to do the research at a faster pace. If not, obviously, you can collaborate with people from other fields and get the job done. But usually, even the physicists I come across have gotten their own set of programming experience, and the same goes to the computer science guy. They do take up certain fundamental quantum physics courses, so to at least get familiar with the different jargon is floating around in the world. Now, coming to your second question, how early can you get a quantum lab set up at the CS department? I think it depends upon the funding and the type of lab you are looking at. If you want to get it like a quantum computer established for the purpose of research, I think you can get that tomorrow if the right funding is possible. 5-qubit, 10-qubit machines are easily getting installed at different locations around the world if you can just get the right industrial partner to support you along the way, right? However, if you are looking at a more commercially scalable quantum computer to be set up at a lab where people can just run like a plug-and-play computer science algorithms for testing out applications, that is still a bit far away, because for that, you would at least need 50 or 100 qubit machines. And for a real-world advantage, you would scale that up to 1,000 qubit machines, which is still very, very preliminary research. So that is, I would say, like at least 5 to 10 years still in the future, but promising.
Okay, that's good. But I'm just going to give briefly a summary of some of the answers that I got from other people. We have some ideas and some conclusions. They're kind of in the style of the answer that you gave us. If we can't do things, we wait like 5 or 10 years, but at least we should know what we are planning for. So some answers, for example, Michael Birchuk, if you know him from Q Control, he said at this point, basically academics are working in the 5-qubit regime, basically. An undergraduate lab, if they don't have money, what they should do is essentially calibrate or measure a qubit or some commercial off-the-shelf kind of devices and have some sort of connection with the foundry. In other words, don't even get involved in fabricating anything. The people at IBM, for example, Zlatko Minev, he said, I don't think you should do any hardware at the moment, especially if you're going to go superconducting. Go ahead and use Qiskit metal. You will have some idea as to what kind of electronics you are supposed to develop. And when things become more accessible, you're going to be good to go. So already I mentioned two different modalities in some sense. So I spoke to people from Bristol and Anthony Lang, and he said, I think bulk optics is the cheapest. Bulk optics probably we can find in any physics department. And the goal would be to create 1, 2, 3 qubits, no error control, just to get things going. And he said, you could set it up that way, but the table that you're putting the bulk optics on is going to get full very quickly. And the students are supposed to know about all the other modalities, because you don't know which one is going to be the relevant one, the one that's going to finally make it. So when we made a recommendation, we said we should be open for all of these. We should not rule out, like you said about the internet, I think it's still valuable to just work with Qiskit or Qiskit metal and build some understanding before, these refrigerators become a little bit more accessible and all the other devices that exist in there, because we are not, maybe industry can actually donate some old equipment if they have, or if they come up with some sort of chip. They can actually, but at this point, it seems to me that there is no answer. Yes, you can try build a quantum hardware lab in an undergraduate program. I think the answer is pick a company, and if you are lucky enough for them to let you work with them, they will share their hardware with you, like Amazon Bracket or IBM or Xanadu through Penny Lane and whatever else they are doing. So work with a company and see if they can share their hardware with you. Don't really try at this stage. If you're a university that doesn't have a lot of money, probably doesn't make any sense to try to establish a quantum hardware lab for a non-physics department. Is that a good summary of what we talked about now?
Yes, yeah, totally. Right on.
Okay. Then this is going to be still in the future. And we could just play with the concepts until we're ready, until the hardware becomes a little bit more accessible. All right, that was just my question. Let's see, what other questions do you guys have? And if you have a question, you can come over here. I think you had a question about business model. But no? Now she does. Shy people. You want me to ask, or can you come over here? I should? Well, quick question here, which I don't understand entirely, but if you sort of understand what they want to ask, maybe she's going to come and explain more. What is Womanium's business model? In other words, there's a lot of volunteering over there. Are you guys making money? And if so, how?
Yeah, that's another question which is very frequently asked because we do a lot of I would say high impact research and pretty good project and help the industries and the academia along the way. The core principle still remains the same. It's a non-profit organization. That is what we are aligned to do. How do we function? It's like many a times there are industries out there who are struggling with their own internal problems too, right? They are not just, even quantum companies, sometimes they struggle with solving different use cases and different hardware problems, software problems, sometimes problems which they're not able to solve in a way of basic level. In that case, they come to us with their problems in the hope of trying this as kind of a test case where they float the problems and see if the students can take wild, creative approaches in trying to solve them. In case they do solve them, the students get their internships out of it, their research out of it, but the industry partner sponsors the entire engagement and gets the solutions their way. So that is one of the routes of the funding which comes to us. And obviously, then there are different grant opportunities. The government heavily supports a nonprofit working in this space. So those kind of things also help us. And on that note, we are a small team, so we are always looking out for more people to join us. So although we advertise more often than not some of the industry partners who will be hiring through a cohort, but Womanium in general also are hiring throughout the year. So in case any one of you is interested, please feel free to shoot me a mail and I can put you with the right person in charge.
Any other questions? Yeah, well, come closer so they can hear you. Just say, this is Shane.
Yes, hello. So this is Shane. My question is, in terms of events that you guys put on, like involving things like it could be in Quantum Solutions Launchpad, are there any future events either online or near someplace in Indiana that we can, in the near future, go to and see more of what Womanium is about? And of course, there are things on the website, but are there places to further engage and see more of what this company has to offer, to see what it has to say, what things that are being done, and all of these things, all these wonderful things?
List of events.
Right. Yeah, so to answer this question, I would like to tie it back to my previous answer. We are a nonprofit and we try to use our funds to the best possible manner. So we do not host in-person events in that capacity because we are a small organization. We would rather divert those funds in supporting more students and helping them learn different technologies, right? But we do organize a lot of virtual programs. There are different webinars happening all around the year where we talk about the different programs, different projects being developed by our student cohorts at the QSL. So if you want, you can, I think follow our LinkedIn channel, which would give you the latest updates, or you can, join our Discord servers. One of the major highlights we have is our upcoming summer training program, which is like this huge, massive event which happens over the summer, completely online virtual training program, This year around, we'll be combining it with quantum and artificial intelligence. So it is quantum plus AI summer program. I believe Dr. Marlu mentioned it last time around, and if not, I can share the links to enrolling in that program via mail, and you can enroll in that. We will be offering 100% scholarships to all students who would be joining that program. So we'll be very happy to host you over there. In addition to that, we are in presence at almost every quantum event happening around the year. So all the quantum tech events, different conferences. In fact, just last month, we were there at the APS March meeting. Coming month, we'll be there at the PQI symposium happening at the Pittsburgh University and many others, right? So we always attend these events. We are invited to share our research and everything. So if you do happen to have any quantum events in your areas, we'll be happy to participate and meet you in person, discuss the different initiatives you are going.
All right, this was a good question, a good answer, and he says thank you, and maybe he's going to have a follow-up. But I do have a question right now in terms of the audiences that you are trying to target. So my model, as from what you, like I said, I heard about Womanium only last year. In 2020, given the situation that we were in at the time, Kiskit had a summer school, and Abe was in charge mainly, but there were a few other people as organizers, and they did it entirely through Discord. And they had about 5,000 people, but they had to stop not recruiting, but allowing enrollment. It was, I think, a significant effort because their goal was to have labs and lectures where you watch, and then labs you have to do something and you submit and it's graded and you get some sort of certificate at the end if you've done the work. And the amount of people was impressive for me at that time, 5,000 people. And the fact that if you went into Discord, at any time of the day, something was going on among 30, 40, 50 people. Like, it doesn't matter what time, there was so much activity over there. Like, really, that channel was not asleep a single second. So my question now is, their idea was, be among the first to tell us that you want in. And if you are among the first 5,000, you're going to get in. Otherwise, I'm sorry, next year. So that means that we are dealing with individuals, and maybe they are students, okay? But there is two categories of people which are a little bit different. So it's not that you're training them because they are eager to learn, they are young, they haven't had a chance. But people who are relevant, for example, existing workforce, they're no longer young, and then high school teachers. These are people who need to be reskilled or upskilled, or something has to happen for them to become confident that they can teach. And it's necessary for them to be able to teach. On a longer time scale, their students in high school. So the question is, do you do anything that is directed mainly to high school teachers at all? And what is that? Because I'd like to know, and I'd like to get involved if possible, I guess.
Sure. Yeah, short answer, yes, we are doing similar stuff. So the program I talked about, that is the summer training program, is kind of similar to the summer schools you mentioned. It's completely open, virtual, open to all. The only difference over here is that we do not have an upper limit. So be it 5,000, 10,000, anyone who is interested, he or she is more than welcome to join us. And we do reach out to underrepresented categories and far off countries, economically weaker zones, and provide them with 100% scholarships regardless of their backgrounds to help them support their education through this program. So that is something which we do. So yeah, that is kind of open to all and winner gets it all kind of thing. During the entire program, we'll have different exercises, different certificate courses, which will just keep filtering down the best participants at the end of it. And the best, a few participants who complete the entire summer course will obviously get certificates, but they will also get shortlisted for the Quantum Solutions Launchpad programs we'll be hosting right after the summer. So this is kind of a pathway to get summer internships too, if that is something which comes to mind from a student's perspective. The other question you asked was how to train the workforce we have, right? maybe industry professionals or high school teachers, or maybe postdocs who are already familiar with the basics, but they want to learn advanced technology to move into the industry. For these kind of specific target groups, we have a more targeted curriculum in place. So this is something which we built on custom demand kind of a thing. We have been receiving requests from a lot of government agencies. We have been directly training some of the top corporate officers. We also have been training some of the high schools and university staff and some of the industry staff who are just getting started into quantum. So all those trainings happens on a request basis, right? You let us know what kind of target audience you have, what kind of curriculum you want, because everyone's needs are different, and we can just put together the right material for you, get the best speakers out there. Do you want it virtual? Do you want it in person? We can make both happen. And accordingly, we set the entire thing up. So that's something maybe which we can take in another call and discuss that further. But yeah, short on it, yes, we do that kind of stuff too.
Okay, that's very reassuring to know, because there's an organization called Qubit by Qubit, which basically is very successful. And I forgot the name of the lady who was I forgot her name, but she's very nice. And
Dr. Kiara, she was also in our program.
Yeah. So the thing is that I had a question for her back in 2021 in December, and I said, can I purchase quantum education from you? And I never got an answer from her. But she kept saying, we offer so many scholarships, high school students join us, and then they are very happy. And I knew that they were happy. They learn a lot. But I say, what if I would I'm a company, I have 20 people, and I just want them to train them because we are starting something else. And she couldn't give me an answer at the time. And that's why in some sense we asked the question about the business model, because it wasn't clear to me how they are making money if they cannot sell any kind of education. But if you say that, for example, if somebody were to come to you and say, we have this group of people who want to teach them this, is it possible to customize a curriculum and then offer something to them virtually or else otherwise? You say it is possible to customize, and maybe we'll pay something, or the company pays something, and then you deliver that type of education, correct?
Right, yes.
Well, that's what I wanted to know, and that's very reassuring. Thank you. Any other questions? Yeah, you want to come here? Here's another question.
Sure, yeah.
Hi there. My name is Shania, and I'm not actually a computer science student. I'm an intelligent systems engineering student doing the biology concentration. And I was a little bit curious, so this might be a little bit more technical, so stay with me here. I don't mean to be too technical with it, but so I'll keep it broad. But when you mentioned specifically with Quantum Solutions Launchpad that it's not just applications within physics, you're also doing applications within neuroscience, biology, chemistry, and like a multitude of fields, right? I was more curious on the exact workflow, I guess. So do you teach your students specifically from back-end work all the way up to front end, like how the 3D fully simulated model looks, with all the 3D dynamics, maybe even a graphical, fancy, GUI user interface, right? But I was just curious about that. Do you teach them everything from back end to front end, or do you specifically concentrate on maybe one aspect of it? Because I know you do it off of pre-existing models and you don't encourage people to build their own models. They can if they want, but that would be more of the engineering side. And I would understand how that could be difficult maybe for somebody with more of a computer science background, where they have all the tools given to them beforehand and they're not expected to develop those models from scratch, right?
Right, yeah. So yeah, very interesting question. And I would like to divide my answer into two parts. For the first one, I would like to speak about quantum computing, right? So when I say quantum computing, we try to teach everything right from the very basics, the fundamentals of what a qubit is and how we start building algorithms to advanced algorithms and actually moving to the very end of real world applications and how these algorithms work there. the quantum computing stack, I think we covered the entire A to Z. However, for other domains, it's a bit difficult for us to bring everything online in a virtual platform. Particularly, let's say quantum hardware, right? We can introduce the different qubit modalities out there, how the photonic systems work and how maybe the superconducting systems work. At the very most, what we do is we provide virtual lab tours so people understand how these actual quantum computers work by like seeing through the camera how the labs are structured and how the different instruments take place, but we cannot provide the hands-on education of dealing with different lab instruments and everything online. That is something we can offer if there are possibilities of bringing the students on site in our partner labs and everything, which we have been doing, but at a small scale. And same goes for quantum sensing and other technologies. We have those trainings, but for a much more smaller cohort with some very specific partners we have. And the second part of your, my answer on other technologies, right? So moving a bit away from quantum, let's say astrobiology, we had a focus which was more on the theoretical side of things. And we did try to have a level start, meaning anyone from any kind of background can at least get started, but it keeps getting filtered out as we move further in the program. So you can stop at whichever breadth you want to do that. But there are other programs too, which I'm not exactly well aware of, neuroscience, neuroimaging, AI, and machine learning, which other teams are handling it at the moment. But they do at least try to bring everything from the ground up, and then they advance by filtering out the students based on their requirements and their learning capabilities.
Right. So you're not making students like develop it by themselves. You're just more so handing them pre-existing tools and technology that you have from your partners, correct?
Yeah, it depends on what you want to do at the end of it, right? The education part is we'll teach you everything, and you'll be more than capable enough to try it out on your own. But once you move into our QFL programs, the Quantum Solutions Launchpad, over there, it depends upon what kind of question you're trying to answer, which the industry has posed. If it's building something right from the very scratch, for example, a few algorithms we did with the warehouse management project, where we were starting right from the very scratch, understanding how these optimization of automated robots work in a warehouse. We built everything from the very first step, and the team developed a pretty amazing final use case, final prototype. On the other hand, the project with Xanadu, there was already an algorithm in place. So we don't have to reinvent the wheel. We just had to fine tune the algorithms further. So both kind of projects are available there.
Right. And I actually have another question because I thought about it just as you were talking about that, kind of like this idea of building it from scratch, right? So since you're an industry professional, I guess I wanted to ask you, as somebody that doesn't have much professional experience, speaking as an undergrad student, where do you see the future of quantum computing when it comes to maybe mathematizing this field? Because I feel like we're seeing more applications. I had earlier, I was in the middle of this lecture, and there's this guest speaker that was speaking about how lately it's become a trend within the technology industry in general to mathematize certain fields, like, where tumor modeling, specifically oncology, is becoming mathematized kind of in a similar way to how I guess like disease models and everything are mathematized. Would you say that quantum computing, like, since I guess like the very basis of it is physics, that you see it heading in a direction where most of quantum computing in the future is going to be more based on mathematization of the models? Sorry,
Yeah,
that was
yeah, understood. So math, I think, is a very beautiful language of how we describe science, right? So if we see it in a very general sense, every kind of scientific knowledge out there eventually boils down to the fundamental math behind it. And the same goes for quantum technologies too. For quantum computing, we are at a stage where the fundamental math has been described, and most of the researchers are not trying to fiddle around with the math just yet. They are trying to build upon it. It's like you have got the base ready with the math, which was done about 20, 30, 50 odd years ago when the initial quantum physics was described and everything. That was math in its pure language, Schrodinger's equation and everything, bra and get algebra and everything. So the fundamental math has been laid down. Right now, everyone is just building on top of it. But the way interesting viewpoint is that once we get to a stage where there's no vertical growth possible, something which has happened very famously with ML and AI models, it's just now coming back to the very roots and trying to redefine the math itself. So most of the ML engineers out there are not exactly programming. They are rather than working on data structures and trying to just build the algorithms right from the scratch, understanding how the math works, how these different types of reinforcement learning or different kind of models work. So the same trend might come into place for quantum technologies as well. Once we are at a stage where we need not grow vertically, we will just go back to our roots and try to understand the fundamental maths behind it. Perhaps there is a way to change it, modify it, optimize it even further. And yes, it will eventually boil down to the way math behind it.
Right. And how many years do you think are projected till we see that application coming into play, I guess?
Yeah, I think this is the kind of question everyone is having their own opinions about it. Quantum technologies might take 5, 10, 20 years from now. It's very difficult to say. A more pragmatic and an optimistic approach would be to say at least 7 to 10 years is what I think, but it may take longer. The problem over here is that both the hardware and the software is being developed in a parallel space. So not only are we unsure about the different qubit modalities out there, we don't know which will be the clear winner. We are also unsure about what the right kind of quantum algorithms are out there. So yeah, the problem is that because we are unsure of both the software and the hardware, it's very difficult to have a set timeline in place. Many amazing researchers are doing a tremendous job out there. As some of the few names which were mentioned previously, Mike from Q Control and a few others from IBM and many amazing partners we have. They're all doing research at a fascinating pace. So yeah, 7 to 10 years is an optimistic viewpoint, but it could take longer than that too.
All right, thank you so much for answering my questions. I asked quite a few.
Yeah, we need to say thank you and also goodbye. So, Shania,
Yes.
could you tell me what year did they put together the first airplane that basically was able to fly from here to the Union, roughly? And who were the people? The brothers, what?
Right.
Okay, in Ohio. What was the year? Maybe 1903?
Yes.
So if you had asked them then, how long will it take until I can fly to Portland? You know, but I mean comfortably. They wouldn't have had an answer right now, say at the time. So we don't have one right now. Specifically, some technologies are not yet developed. We are not sure entirely that those could be in fact effective. As far as the math is concerned, my point of view is that we do not have direct access to the world of the very small. And therefore, the intuition for us is inexistent. So then the only option that we have at this point, the only substitute is mathematics, which we need to learn and we need to get access to before we can build an intuition in that sense. So you're not going to find anybody who would say, don't worry, in 5 years, 10 years, or 15 years, this is going to happen. But you can form your own opinion. So these are very good questions. Thank you very much. We also got to the end of our event tonight. I want to thank you so much, Vardaan, for being kind enough to come here tonight and taking all our questions.
Yep. Thanks a lot for inviting me, Adrian. And
right.
yeah, let's see this as the first step to our long-lasting collaboration and many more to come.
Very good. Thank you once again. Have a very good night. And once again, thank you for your kindness to come over and talk to us.
Thank you. Have a great day,
Bye.
everyone.
Bye-bye. So I'm going to go and say, what do I do? I'm gonna stop recording. Yeah.